So we want to find two numbers with a difference of 160 and whose product is a minimum. So the first thing is we're going to write the x minus y equals 160. So two numbers, we don't know what they are, but when we subtract them, we want them to be 160. And then whose product is a minimum, so we can set this up as p, just going to be a function of x, is going to be x times y, and we want that to be a minimum. So what I need to do is get this top equation in terms of x. So we need to solve this for y, so I would subtract x on both sides. That's going to give us a negative y equals 160 minus x. And then I'm going to divide each term by negative 1, which is going to give us y equals negative 160 plus x. We have y by itself, and now we can take this value of y and put it into the equation below. So it's going to be p of x is going to equal x times negative 160 plus x. And now I'm going to distribute the x, which is going to give us negative 160x plus x squared. So now we need to take the derivative. That's going to help us find the optimization points or the critical points. Derivative of negative 160x is going to be negative 160, and the derivative of x squared is going to be 2x. And now we need to set this equal to 0 and solve, because that's going to be the critical points. So we're going to have that 0 is going to equal negative 160 plus 2x, and this is just a little bit of algebra. Add 160 to both sides. That gives us 160 equals 2x, and then we divide by 2. And that's going to give us that x is 80. And then we got to figure out what the value of y is. We can use this equation right here, be the easiest one to use, and we're going to put 80 in for x there. So that's going to be y equals negative 160 plus 80, and that's going to be a value of y equals negative 80. So we have our two numbers. It's going to be 80 and negative 80. And just as a quick little aside here, an extra bonus, when we take the second derivative of this, that's going to give us that p double prime is going to be, the derivative is 2. And since that the derivative here is greater than 0, it's going to be a local minimum